Hi there, MathsRush will be bringing you equal fractions concept today. So, why this concept? Okay, why equal fractions concept? Because in my opinion, it's one of the funnest concept that I've applied other than using model. Okay, and this concept applies from P4 onwards all the way to P6. Of course, P4 will be really easy and P6 will be slightly difficult, of course. There's the advanced level of this concept, so there will be another video for that. So why is it called equal fraction concept? It's because the word equal appears, okay, or synonym to that. Fractions of two different persons, so half of Avril and 2/3 of Beth, as you can see, indicating to two different people. So once you see this kind of question, you can apply this common numerator method instead of model. Okay, of course currently it's rather easy to do because the fraction is rather friendly for this question, so the model method might be easier to apply. However, as you go on to higher level of difficulty, you might have a bit of trouble on doing the model. Okay, I apologize, this is my first time using a tablet to write down everything, but it's much better in my opinion because I get to show my working now. Alright, so how do you do this question is that simply translate the first sentence, half of Avril's money. So half of Avril's money is the same as 2/3 of Beth. So simply just translate this. Common numerator means that we need to make the numerator the same. So by making numerator the same, I need to make use of equivalent fraction times 2/2, and then my next working is 2/4 of Avril's will be the same as 2/3 of Beth. Okay, just by writing this statement down, I can simply say that Avril has 4 units based on the denominator and Beth has 3 units. Okay, so this is the method, and I can conclude saying that because Beth has $5 less than Avril, I can say that Beth is 3 units, Avril is 4. I can say that 1 unit is this $5. Alright, so I'm going to put a stop to here first. I'm going to do the model now to show you that is it really true 4 units for Avril and 3 units for Beth. So here's the explanation. So of course, for model, we need to have this. Avril, half of Avril's money, so I need to draw a complete model for Avril. Okay, and then I need to half it. Okay, this is my first time doing the model with a pen, so bear with me. And then it's equals to 2/3. So I need to say that this half here is equals to 2/3. 2/3 means I need to draw 2 units for Beth. Okay, 2 units for Beth. Okay, and Beth has a total of 3 units, and then we need to draw this 1 more unit over here. Okay, as you can see that Avril's 1 big box is the same as 2 boxes of Beth. I need to split this into 2 and split this into 2 as well. So yes, we can see that Avril has 4 units now and Beth has 3 units, and we can say that 1 unit is 5, which is the same over here. Okay, sorry, it's rather hard for me to do that. Okay, anyway, 1 unit is equals to $5. So here comes your working. And how much do they have all together? It's 7 units. Is equals to 7 times $5, which is equals to $35, and this is my answer. Yeah, so as you can see, the model now is still rather friendly, so it's much easier to draw, but if the fraction change, it will be extremely difficult. Alright, so now what we're going to do is going to move on to a second question, Edmund and Fong. So let's read the question. I'm going to pause the video after that for you to try the common numerator method. So first, let's read the question. Edmund and Fong have 230 marbles altogether. 2/5 of Edmund's marbles is equal to 3/4 of Fong's marbles. How many marbles does Fong have? So for this question, why don't you use the common numerator to try first? If you are not so sure about common numerator and you're so confident about model, please go ahead and try. So please pause the video and then resume it when you're ready. Okay, so right now we're going to use the common numerator immediately to solve the question, as what I've mentioned earlier. First of all, just translate the fraction statement. 2/5 of Edmund is equals to 3/4 of Fong. Okay, next, make numerator the same. To make this the same, the common numerator of 2 and 3 would be 6. So the left side, I need to multiply by 3 out of 3, which I get 6 out of 15. Okay, yeah, you don't have to write times 3 out of 3, it's understood. Okay, is equals to 6 out of 8 of Fong. Okay, to make numerator the same, I have to times 2 to both sides, to the both numerator and denominator. From here, I know Edmund has 15 units and Fong has 8 units. From here, we know that there's a total of 23 units for both of them, which is equals to 230 marbles, right? So 1 unit, when we divide 230 divide by 23, we will get 10 marbles. And how many marbles does Fong have would simply be 8 units based on the denominator over here. Of course, you don't look at the O units anymore after that. Alright, so 8 units would be 8 times 10 would gives you 80 marbles, and that's the final answer. Alright, as you can see, it's really easy. And now we're going to try to draw the model to show you, to differentiate how it looks like. And for this now, the fractions here are rather unfriendly, so it's rather hard to draw. So anyways, let's draw Edmund's 2/5. So Edmund 2/5 means that I need to draw 5 units for Edmund. Okay, and students tend to draw their models very small, so I'm going to try to replicate how a student draw the model. Okay, it's a bit uneven because we are not robots anyways. Okay, and for Fong, 2/5 means that I need to concentrate on 2 units of Edmund, and then I need to draw 3 units for Fong, and then finally I need to draw 1 more unit for Fong because he got 3 out of 4. Alright, so concentrating these 2 big units here and 3 units below for Fong, we need to make them the same, which means that for Edmund's unit I need to divide them, to cut them into 3 units each, while for Fong I need to cut into 2. So let's cut, and you'll see how tedious that most students will face because they are rather skeptical in drawing the model too big. So this is the problem they face. Okay, it looks really difficult to draw and it's very uneven. Okay, and for Fong, we need to divide them into 2. Yeah, so one problem now is that, oh no, I had cut so many, I don't know what to do. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, and then it's really difficult to count. So as you can see, the fraction is rather unfriendly for this question, and of course it will most likely won't be as friendly as others as well for difficult questions. So I hope that you would prefer this method as common numerator method as compared to the model. And yeah, so let's move on to the third question. Gavin and Hillary. So for this question, why don't you take a short pause on this video and try out this question before I continue. Alright, so just chill for a bit, pause it now, and then we're going to resume in a few seconds. Yep, welcome back. We're going to continue with this common numerator method, equal fractions concept. But the problem is there's only one fraction there. What should we do now? Okay, you should know that percentage and fraction and ratio and decimal are all related. 80% is 4/5. If you're not fast in converting, you can rely on calculators, since most of the time this is paper 2 question. If you can't, I hope that you can memorize the percentage to fraction conversion quicker, so that you can save time if it appears in paper 1. So 4/5 of Gavin's cookies baked was equal to 3/7 of Hillary's cookies baked. So what do we do here is simply just translate this statement into this mathematical, whatever you call that, Hillary. Alright, so what we're going to do is make numerator the same, and on the left side I need to multiply by 3 to make it 12, because common numerator will be 12, and the right side I have to times 4. Yeah, so from here I know that Gavin has 15 units and Hillary has 28 units. So what fraction of the total cookies was baked by Gavin? So Gavin baked a total of 15, and the total for both of them would be 15 plus 28, so the answer would be 15 out of 43. And there we go. Imagine if you're going to use the model for this question, how many units must you draw and cut and count, and yeah, it's just so ridiculous. Yep, so we have reached to the end of the video. I hope you like this concept. There's a much higher level difficulty for equal fraction concept, and I hope that you apply it whenever you see this question of equal fractions. So that's all, and see ya, adios.